In this video, we're going to just explain how area models work, where they came from, why they're useful. So say we started way back when we were multiplying, all right, two binomials. So here we have the quantity x plus 7, and we need to multiply it by the quantity 3x minus 2. You might have been shown this, or you might have seen this before, using the distributive property. So x needs to be multiplied by 3x, x needs to be multiplied by negative 2, 7 needs to be multiplied by 3x, and 7 needs to be multiplied by negative 2. Especially when there are more terms here, this can start to get cumbersome and confusing, keeping everything in order. Let's just do it now, and then I'll show you why the area model might be more helpful. So x times 3x gives us 3x squared. X times negative 2 gives us negative 2x. 7 times 3x gives us 21x. And 7 times negative 2 gives us negative 14. Then we combine like terms. So we have 3x squared. That one didn't have anything to combine with. Negative 2x plus 21x gives us negative 19x. And then finally, the last term is negative 14. Now, an area model can just help you get things organized. It actually turns out an area model is maybe not the most useful in this case, but it will be so much more useful when we're breaking things down that it's good to use it here and understand how it works. So if you were going to use an area model to multiply, you would take your first factor. It actually doesn't matter the order you do it in because it's multiplication. The order doesn't matter. So I'm going to put this one up here. So this is x plus 7. I'm going to think of x and 7 now separately when I multiply. And then this is 3x minus 2. So these are my two factors. And I'm going to multiply x plus 7 times 3x minus 2. So this is area because that's how we find area, right? We multiply base times height and we find the area, which is multiplication. So each box here is the product of the things that are on the outside. So the first box here in the top left is the product of 3x multiplied by x. So 3x times x gives us 3x squared. Remember, x times x gives us x squared. This box on the right here is the product of 3x and 7. So I multiply 3x times 7 and I get 21x. Then I multiply negative 2 times x to get negative 2x in this box, and negative 2 times 7 to get negative 14 here. As you can see, these are the same terms that we got when we did it with the distributive property, and we're still using the distributive property. Things are just a little more organized than trying to follow our arrows. And now to get this negative 19, so the 3 and the negative 14 were here, and to get the negative 19, I just have to combine on the diagonal. The nice thing about this box too is that if we had more terms in our factors, we could just kind of make our box bigger and bigger, and we could multiply. What'll always happen is your like terms will be along the diagonal. So the solution, what this gives us is really 3x squared, and then 21x and negative 2x are like terms. We can combine them. And then finally, we're left with negative 14. So same answer. Even if you like using this method on the left, I want you just to practice some using method 2. That'll help you when you go to work backwards.